Hello everyone, my name is Jennifer. In this video, I will be walking you through my individual project 2 I did for my data engineering class. To give you an overview of this project, let's start with the README first. First is the project purpose. This project demonstrates a performance comparison between Python and Rust implementations. It includes ETL processes and CRUD operations on a Goose dataset. The main steps this project includes data extraction from a CSV file, data transformation and loading into a SQLite database, also the CRUD operations, and also the performance comparisons between the two languages. Here is the project structure. In this structure, we have a Rust SQL directory, and inside it, we have the librust and main.rust file, and also the cargo toml file, which manages dependencies. For Python language, we have mylib directory and also the main.py file to store the Python scripts for data extracting, querying, performance comparison, etc. The data set I used comes from the 538 public dataset called Goose rawdata.csv. Next, we come to the implementation part. To help you better understand this part, let me walk you through this part in VS Code. In this VS Code, here you may find it familiar. This is the project structure I showed you before. And let's start with the Rust implementation. To run Rust, we first need to change our current parent directory to Rust SQL project folder because we need to rely on the cargo toml file to execute the cargo commands. And then we can run the cargo clean to remove any previous builds and get us a new build. This step can help us avoid any issues caused by outdated or incompatible compiled files. Next, we can use the cargo build in release mode to compile the project. In release mode, Rust applies various optimizations to make the code run faster, which is beneficial for the performance. Finally, we will run the cargo run release release similar as before. Running in release mode can allow us to test the performance of the optimized code. After cargo run, we will get a CSV file called rustbenchmarks.csv. This CSV records the speed and memory performance of Rust code here. And next, we are going to look at the Python implementation. Since Python's mylib and main.py files are in parent directory, so we need to move up to parent directory using cd space two dots, and then run the python main.py in the terminal. Python script performs the same functions as Rust, that is to let's extract data, transform and load data, and also perform the CRUD operations like the Rust extract, transform and load, query, CRUD operations. Let's see. After running python main.py, we will get these results. The result of a Python benchmark CSV here, and also a Python performance plot, and also this table, performance comparison table. Based on these results, we can see that in overall, Rust runs 1.1 times faster than Python. And in terms of memory perspective, Rust also uses significantly less memory than the Python. Here is the implementation part. Let's go back to the project README. This is the brief conclusion for the performance comparison analysis. One interesting thing that I find about the Rust memory is that there are some zero value in Rust memory column, and the potential reasons may be that we run some optimized processes before, such as cargo clean and cargo build in release mode. And also another potential reason may be the CRUD operations may have been very lightweight after the previous steps. In this project, I used GitHub Copilot as a coding assistant, especially when I needed to translate Python code into Rust code, and also for situations when I needed to find the potential reasons for the code errors. It is pretty useful. And the last thing is the Rust binary. If you'd like to try the Rust implementation yourself, I've also made an optimized binary available for the download. You can just click this link and go to this GitHub page and scroll down to the artifact section here, and you can just click this download button to download it. Okay, this is my video demo for my individual project too. Thank you for watching. I hope this demo helped you understand more about the performance differences between Python and Rust, and also feel free to reach out with any questions, or you can just try out the binary for yourself. Thank you.